in complex fractions today. So here's the first one that we're going to work out. We've got x plus 1 over x minus 5 plus 2 over x plus 3 all over x over x plus 3 plus x over x minus 5. So we have two little denominators here, x minus 5 and x plus 3. So those are going to make up our LCD. Now remember the point when we are simplifying complex fractions. It's not to get a common denominator. It's to eliminate all of the little denominators. Okay, we are trying to eliminate all the little denominators. So we're going to go through, and we're going to put parentheses around any numerators that we need to put parentheses in. And we're going to multiply each of these by the LCD. So x plus 3, x minus 5. X plus 3, x minus 5. Now, some of you are going to get to the point where you know what's going to cancel, and so you don't necessarily have to write all this out, and that is fine, but please do not jump the gun on me, all right? Let's do this to make sure that we fully understand what's going on. Then if you can start skipping steps, go for it. All right, so first rational expression. We've got x minus 5 in the numerator and the denominator, so those cancel out. So we've got x plus 3 times x plus 1. Followed by a plus sign. The x plus 3's cancel for the second one. So we've got 2 times x minus 5. That's our numerator, because we eliminated those little denominators. So now we're in the denominator. For the first one, x plus 3 cancels. So we've got x times x minus 5. Don't miss the plus sign. Then the x minus 5's cancel. So we've got x times x plus 3. We cannot cancel anything at this point because of the plus that's in the numerator and the plus that's in the denominator. So before we can get to the point where we can simplify anything, we've got to multiply everything out. We've got to multiply everything out. So x plus 3 times x plus 1, we multiply that out, we get x squared plus 4x plus 3. We distribute the 2. We get plus 2x minus 10. In the denominator, we've got x's to distribute. X squared minus 5x plus x squared plus 3x. Now we combine like terms. X squared plus 6x minus 7 over 2x squared minus 2x. Can we factor? Yeah. Yes. X plus 7 times x minus 1. Positive 7 times negative 1 is negative 7. Positive 7 plus negative 1 is positive 6. In the bottom, it's a GCF. If we take out 2x, we're left with x minus 1. We can cancel the x minus 1, so our final answer is x plus 7 over 2x. Ta-da. All right. Let's make sure we've got it. Let's do another one. Number 3, x minus 7 over x over 7 minus 7 over x. This one's not going to take us quite as much as the last one did. So our numerator doesn't have a denominator, okay? So we don't have to worry about anything there. All we've got for our LCD is the 7 and the x from the bottom. So we got 7x, 7x, 7x. The numerator didn't have a denominator. Nothing cancels, so I'm going to go ahead and multiply that out. 7x squared, or actually, no, I'm going to leave it in factored form because I don't have anything to combine it with in the numerator either. Okay? Leave it in factored form. Okay. In the denominator, for the first one, the 7's cancel. So we've got x times x, which is x squared. For the second one, the x's cancel. So we've got minus, don't lose that minus sign, 7 times 7 is 49. Like I said, I'm leaving the numerator in factored form because I don't have any terms to combine in the numerator. And my ultimate goal is to be able to factor and cancel. So if we factor the denominator, difference perfect squares, bless you, the x minus 7's cancel. So 7x over x plus 7. That's it. Okay? Some of them are going to be quick. Some of them are going to take a little bit more work. But they all require the same steps. Let's do one more. Number 4. X plus 4 minus 1 over x plus 4 over x plus 11 plus 48 over x minus 3. So this is a complex fraction because there are fractions within the fraction. But we only have 2 rational expressions, so to speak, in here. The first one doesn't have a denominator, so let's just put it over 1. Sometimes that helps people visualize. Okay? Put the x plus 4 over 1 and the x plus 11 over 1. So our LCD, we have 2 different denominators. We've got x plus 4 and x minus 3. You don't have to worry about the 1. Multiplying by 1 doesn't do anything. So, x plus 4, x minus 3, x plus 4, x minus 3, x plus 4, x minus 3, x plus 4, x minus 3. Okay, so for the first one, nothing cancels. So everything just comes down. X plus 4 times x plus 4 times x minus 3. Yes, I know we could write that as x plus 4 squared, but chances are we're going to have to multiply this out, so I'm just going to leave it the way it is right now. In the second one, first of all, it's minus. Okay. The second one, the x plus 4's cancel, and we've got 1 times x minus 3. Well, I'm just going to leave the x minus 3 in parentheses because it follows a minus sign. So leave it in parentheses. Over. Nothing canceled in the first one. X plus 4, x minus 3, x plus 11. This one was plus. Here, the x minus 3's cancel, so we've got 48 times x plus 4. Now, at this point, we are supposed to multiply out and simplify, hopefully factor in something cancels. But if we multiply this out, this is going to get really big, is it not? X plus 4 times x plus 4 times x minus 3. We're going to end up with x cubed eventually. So let's look and see, does this expression right here, these 3 binomials together, have anything in common with this one right here? X minus 3. Okay. Think of it kind of like when I introduced factoring by grouping to you guys. These both have x minus 3. So I can factor that out. So if I take it out, I've got x plus 4 times x plus 4 minus 1. I got to hold its place there. Okay? Supposed to. It's supposed to be done before the thing's not there. All right. X plus 4 times x plus 4 minus 1. Okay? So we've made our multiplication a little bit more manageable here. Okay? Can we do a similar thing in the denominator? Similar, not exactly the same, but the first term and the second term both have x plus 4. Okay? Now, it would be great if we could have factored out the same one from the top and the bottom, because then we could cancel them. If both of those were x minus 3's in front, we could cancel them. If both of them were x plus 4's in front, we could cancel. They're not. Okay, so at this point, we need to simplify what I have in the brackets. Okay, we need to simplify that. So that means we need to multiply it out. Okay, I know this is getting a little lengthy, but it could have been even longer if I didn't show you all the factoring thing. Okay, so x plus 4 times x plus 4 is x squared plus 8x. 4 times 4 is 16, and then we're subtracting 1 from the end. So I'm going to go ahead and just write that as plus 15. Is that okay? 4 times 4 is 16, and then I subtracted the 1 that came after the parentheses. Okay, and the bottom. Let's multiply that out. We've got x squared plus 8x minus 33, but then we add 48, so negative 33 plus 48 is 15. Well, isn't that interesting? They started out very, very different. X plus 4 times x plus 4 minus 1, and x minus 3 times x plus 11 plus 48. Would have anybody have thought that those would have ended up giving us the exact same trinomials? I would not have. We can cancel those. They're exactly the same. We've got just multiplication in the numerator and in the denominator, so we can cancel them. So all this problem boils down to x minus 3 times x plus 4. Yes, ma'am? Yes, it would take a lot longer if you did not do that factoring. I honestly don't know if you could get it in the factored form if you didn't factor it out. It would just end up being a really weird polynomial. Okay, so you need to start being aware to look for things like that. When things start getting big, see, do I have something in common that I can factor out before I have to start multiplying and simplifying? Okay? All right.